Red box for Sibley Volcanic Regional Preserve. So this is what they're different volcanic rock. Looks like a melted brick. Red color from steam action on hot fragments. Ripple marked pebbly sandstone. Conglomerate. Vesicular basalt lava. Forming escaping gas. More plasma. Cretaceous sandstone.
Next floor. I want to know whatever the dots and boxes. What area?
Lithified ash. Basaltic resin. This is what they call Round Top Mountain. So-called ancient volcano. This funny little plaque here. We know that camels, zebras, all the animals in Africa came from here. Long-necked camels and three-toed horses. It says, examine the planted eucalyptus trees and Monterey pines along a portion. Is this really a volcano? There's a map of the ridgeline Wildcat Fault area looking north. So you have Mount Tamalpais, Grizzly Peak, Volmer Peak is where the rock wall ruins are on the other side. And here's the Quarry area. So they have these geological markers. This is supposedly a massive dike or I think lava tube from the volcano. Do you notice how it looks like it was molten material? There's like these humps, but I mean, this was all carved out to put in this water tank. Okay, so it says walk up the paved road to the East Bay water tank to see a dark basalt dike, a feeder of lava to the crater that cuts through a sequence of tough breccias, grayish brown, and pebbly mudstones, light gray inside and near the crater bottom. Saying this is a feeder of lava. I mean, this looks like your basic basalt. So here's looking down. Basically they're trying to say that This is a lava tube, but it's laying down, you know, going horizontal towards where the crater was. There's no more crater. But then, if you follow this trail over here, there's this little outcropping. Very strange rocks. It's just this rock is very much blockish, like it has structure to it. You'll see up top. It's kind of weird. I found these two boreholes. Why would anyone drill a hole? This might have been part of the quarrying operations. This doesn't make sense if the volcano is laying on its side. Where does these rocks come from? So you can actually see where they were cutting blocks from here as part of the quarry. And some of those are used still in the streets in downtown Oakland. Other parts. This is a strange markings here. Does that look naturally? Does that look natural? Look at these, like, striations or cut marks. What the heck? Melted brick structure. Here's where they say this lava dike. Alright, shout out to Kairos, brought my hammer this time. This stuff is really brittle. That's why they use it for aggregate or gravel building roads. It's really weird. You can see like where it was flowing. This kind of globular look. Okay, so here's round top, the summit of those towers. Now we're at marker number 2. It says this pit was made by quarry operations in which massive basalt lava was removed. The pit exposes the interior of the round top volcano. You are standing on bedded tough breccias which filled much of the crater, settled at times into a small lake. The steep wall across the pit consists of lava that capped the crater after it was filled. Eventually the round top vent buried itself in basalt flows. Okay. Quite a story. So this is where the crater would have been, but it's laying on its side from the supposed tectonic uplift, but it might have been rapid sedimentation or the earth expanding. That's what causing the uplift and crustal displacement. So so this crater was, they say it was formed by the Kaiser Sands and Gravel Company that dynamited, blasted, and quarried the gravel to build the roads and whatnot. And then this goat herder lady that came and made these labyrinths, well, the one labyrinth and then others, different labyrinths scattered around, but there is a petroglyph spiral carved into a rock. And you have Mount Diablo in the distance. We're approaching the blast site inside of the volcano. They're dynamiting here. This looks like a huge crater from like a, I don't know what. So I'm noticing is all these like quartz veins running through the strata. That could be calcite. But a lot of these rocks have seashells, you know, embedded in them. Again, that's where supposedly the crater would have been. This rock right here, the only thing that looks volcanic, in my opinion. I mean, it's like a glob of melted something. And I have found quartz in here. I'll show you. You can see a close-up view what we're dealing with here. Don't really know what to make out of this. So those white areas are like quartz. Some of them are fossils, crystallized shells. It's like a chunk. And there's all these like air bubbles. Very suspect. Does this look like you're inside of a volcano crater? 10 million years old? What the heck? It's like glass. Glassy like substance. Whoa! Oh, it's just a beetle. Look at this stuff. It's like shells, fossils embedded in this. So was this underwater when it erupted? Or was there a tsunami at the same time? Here's the North Quarry. Massive basalt was removed from this major quarry pit. The north wall shows a set of thick lava flows tilted on the edge, nearly vertical. The well-defined layers near the top of the face are jointing units resulting from shrinkage caused by cooling. They are analogous to the basalt pillars of Devil's Postpile in the Southern Sierra. Alright. So check it out. It's over there is where they say the crater was. And the other quarry pit. It's the North Quarry pit. See these mass layers. Again, this looks just like another giant blast site. Whether it was here or not, when they started quarrying, we don't know, because it's very hard to find any photos of the quarrying operations before they did any blasting. It was run by Kaiser, not open to the public until like 1980. And again, it has these band of like quartz. I mean, it looks like some kind of electrical discharge here. And there's maybe in connection with volcanoes, with plasma energy. I don't know. So there's Round Top. It's this quarry pit. And I guess even weirder. These like scattered red boulders, red rock. These trees are growing right out of them. Right away, of course, you notice the color, the lichen. See how this lava, whatever it was, flowed down. Boulders. Here's this cliffside where some of the rocks have fallen down over time. Check this out. It's very, very suspicious. Here's geological marker number 8. This huge reddish brown block of lava fell from the cliffs to the upper right. The lava cooled and hardened while it was still moving, resulting in dramatic fragmentation known as autobrecciation. This is the rock they're talking about that came from up there. Amazing how it can auto-brecciate in right angles. Yeah, definitely was molten, vitrified, reddish brick color material. Here's more auto-brecciation. Parallel lines. So if it's windy, this is those areas they call a bake zone. So to the right is basalt lava So what I find odd about saying this was laying flat and then tilted over on its side. So when it was formed, it was. And this is the lava. And this is the part of quarrying. Okay, this is funny. Number 10, the brick red knobs in the foreground and rugged outcrops of the same color on the skyline are made of cinder that flew from round top and landed while still hot, so the pieces welded together. Are you kidding me? Okay. Flying blobs of molten cinder. 11. The major valley to the north across Highway 24, which is basically just over those hills, is Siesta Valley. Coincides with the axis of the Siesta Syncline, a great fold that has lifted up thousands of feet of rocks on both sides. Or was it lifted up? You are standing on the southwest limb of the fold, which includes all the rocks in Sibley. Okay. And then I think this was what inspiration for the labyrinths. If you can make that out, I'll pour some water on it. Spiral petroglyph. Hard to say how old it is. Probably not that old, but it is weathered, but the coloration where it's been chipped is hasn't turned that brownish color yet. Interesting though. Oh, look, it goes all the way over there. Oh, you can see someone was trying to put some water on it. You can see that it's a pretty well defined spiral. Would have taken just a few days, maybe a week. I don't know how many people. So here's a boulder with all these like crystallized fossils or something. So here's what another one we call these baked zones. You got the lava on the left, red brick color. They call it baked. I mean, come on. Why is that? I can't figure out what this was. Number 7 before you is a basalt flow, massive at left, rubbly to the right. The lower parts coming into contact with cold land surfaces harden early and are often jumbled by turbulence and drag. The rubbly part of the flow is filled with vesicles caused by gas pockets, which are later filled with chalcedony, opal, calcite, zeolites, and something caledonite. Interesting. This vein running down here. It's like calcite or something. 6. This is a sequence of basaltic tuffs, ash, lying on top of a dark lava, far left, all tilted steeply to the east. The base of the tuffs was baked red, probably because the lava below was still hot, steaming when the ash landed. At the top of the sequence, there's another lava flow, far right to the right of the posts that baked the underlying tuffs red. Okay, so they're talking about this. It's hard to see what the sun's in there. Here's the baked tuff. Okay, number 4. Before you is a wall with basalt on the left and a rim of mudstones on the right. Kind of hard to see with the grasses, but basically it's saying the bedding in the mudstones gives the appearance of drag folding resulting from relative uplift of the lava occurring in the past 10 million years. Alternatively, the disruption of the mudstones may have occurred earlier at the time of volcanic activity. This site was close to or within the wall of the volcano and would have been subject to slumping, sliding, and plowing. Wow. Some lava rocks. Look at how this just got like the iron oxide veins running through it. Geological marker number 3. This road cut, I'll give you a perspective. So here's the road. This road cut exposes Orinda Formation river gravels, sands, and mudstones. The red, when moist, streaks and layers in these riverbeds were caused by oxidation of iron in the sediments. Where did the iron come from? Such vari-colored red beds sometimes contain fossils of plants and animals. Elsewhere in the preserve, bands of more intense red are found at the tops and bottoms of lava flows, where iron was oxidized and reddened by baking and steam action. These bands are called bake zones. They love that term, bake zones. There's the gravel and stuff from the Orinda Formation. I'm not buying it. It just doesn't seem like what they're saying it is. Or it was caused by something else. What's weird is this whole area was closed off to the public until like 1980. Kaiser Sand and Gravel, and then I guess they gave the land for a park.